So at this point, I hope you guys are very comfortable doing just regular unsigned conversions, going from decimal to binary, binary to hexadecimal, and all the combinations above. But now we're going to move into 2's complement, which is a sign world. We have now positive and negative. Anytime you're dealing with this is the question you're going to be asking yourself. Is the number negative? If the answer is yes, we're going to have to follow 2 steps. We're going to have to flip the bits, and we're going to have to add 1. If the answer is no, then we're ready to go. It's just like any regular unsigned. It's just a straight straight conversion. So let's take a look at 1. Let's say we are in this world, in a 16-bit signed integer world, 2's complement, right? And if I ask you, I want you to convert the following number to decimal notation, F1BC. So, what is the first question you ask yourself? Is the number negative? How do we know if the number is negative in hexadecimal notation? Well, you're going to take a look at the very first digit. If this digit, if this one is greater than 7, then the number is negative. And if you try to convert each of them to binary notation, you'll find out that this is the case. So if this is now, what do? I have to flip the bits. So that will be the very first thing I do. And I'm going to start converting my F. It's going to go into 0, 1. After I convert 0, 0, 0, 1, it will be E. B will be 4, and C will be 3. And this is true if you just do one by one of the conversions. Remember, I showed you in class that it's a good habit to have all the hexadecimals 0 through F, and then the opposite from F to 0, and this will give you a quick way of doing flipping the bits. Are we done? No, remember, we have one more step that we have to do, which is adding 1. So we're going to come and we're going to say, we're going to add 1. So 0E43 plus 1 will be 0E44. Now I'm finally ready to do my straight conversion. And if you convert each of these numbers to their binary equivalent, this is what you get. And finally, you're ready to do your decimal conversion. One thing you have to keep in mind, remember, do not forget the negative sign. You're going to get all excited. You're going to write 3652, and that's probably going to be one of the choices in your quiz. So make sure you do not forget the negative sign. Okay? But now, what if we're going to go the other way around? From an actual negative number, if I ask you, I want you to convert this decimal number, negative 5232, to hexadecimal notation. Okay? So what is the first question we ask ourselves? Is this negative? The answer is yes. So we're going to have to flip the bits. But first I need to get the regular bit. So I'm going to take this part, the 5432, and I'm going to convert it, do a straight conversion to binary. And this is what I get. 001, 01, 01, 00, 11, 1, 0, 0, 0. Which is equal to 1538. Now, the next step is going to do, now I am ready to flip the bits. As I say, in any of these steps, please pause the video, try it by hand, and then compare it with the video. So pause the video and flip all these bits, remember? All the zeros to 1, all the 1s to 0, or do the flipping the bits of the hexadecimal notation. Okay, so hopefully you pause, you did it by hand. Now, this is what you get. 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 0, 1, 1, 1, which is equivalent to EAC7. Am I done? No, I need one more step, and do not forget this step, adding the 1. Doesn't matter which direction you go, you always have to do these 2 steps. Flipping the bits, adding 1. So adding 1 to EAC7 will give you EAC8. So So I hope this gives you another example in how to do 16-bit sign conversions. If you still have any questions, please let me know, because from this point on you are going to be asked every single quiz how to do sign conversions.